Good morning, ladies and gentlemen. Welcome back. It's Monday, October 26th, and hopefully the cohort A has already finished their first test. Yay! And they'll say that they did really well. Today's topics we're going to kind of cover. Oops. Hopefully you guys can see that. We're going to talk about coterminal angles, radians, and a little bit of trig identities from the package. I'm doing things a little differently to support us. And the coterminal lesson is actually pretty easy, but I didn't want to put it on our first test. So here we go. Coterminal. Notice the word terminal, it's obviously related to the terminal arm. So I do a terminal arm here, and co means related. Now, in your packages, ladies and gentlemen, there's things called correlated angles, which we're never going to talk about. So if you see in your package, just let me know, ask me about it, and we'll cross it out, okay? Correlated angles. But coterminal are basically angles that are the same with multiple rotations. And notice the definition I wrote in our lesson right now is really easy. I decided to write it this way, plus 360 degrees, n, where n represents the number of rotations, or n belongs to natural numbers with the rotations. Notice the negative. The negative means, well, going clockwise. So this is counterclockwise, this is counterclockwise. Let's start again. This is counterclockwise, this is clockwise. So in our sketch here, look, n represents the number of rotations. Yeah, so number of rotations. So in our first example, just to make sure we're okay, we're going to do one full rotation, right? So notice this is our angle in standard position, 30 degrees, everyone okay? Going counterclockwise. And it is in quadrant 1, but regardless. And if we continue this rotation, notice it went all the way around 360 degrees. A lot of you can tell me the coterminal angle. A lot of you can do the simple math. 30 degrees, that's the original angle, plus the one rotation. I'm not going to put the n is equal to 1, but okay? Can someone do the simple math? 30 degrees plus 360? 390, right? 390 degrees. What I'm trying to share with you, even though 390 and 30 degrees, they're not the same numbers, they're going to give the same answer. Notice, sine of 30 degrees is equal to the sine of 390 degrees. And if you want, you can check your answer, right? How? Use your calculator, and you should get 1/2. Before we continue, everyone okay? Did I make a mistake? Floral.
Just a question. So for the red line, which is terminal, does it start from the terminal arm? Like
Yeah, terminal arm. So it has to end at the same, has to be the same angle, right? So when you do a rotation like this, you rotate like that, I end in the same slot. 360. Right? That's why a lot of students actually understand this. If you're a dancer, if you're a figure skater, if you're a snowboarder, windsurfer.
what does it say? Theta something equals 30 plus 360?
Oh, COT? Oh, I should put coterminal.
Oh, okay. Thank you.
Yeah, coterminal. Because I just trying to show it's a multiple, right? Let's see if you guys can do this extension question. I'll do this in blue. Up here. Where is when theta is equal to 900 degrees? So notice it has to be in standard position, right? So 900 degrees. Any volunteer have an idea? What would you do mathematically? Eric?
I think you subtract like 360
Yeah, so some people always do it other ways. I like what Eric suggested. Subtracting is a little easier for some people, but some students would do rotations like this, and I'll just show you really quickly. Starting there, going counterclockwise, so 360, then 720, and then 720 plus a little bit more. Or we can do what Eric said, do 900 degrees minus, I think at least 2 times 360, which is what?
180.
Alright, so the resultant angle is actually this one. But just to show everyone else, that's one rotation. Oops, let's try that again. That's one rotation, that's another rotation, right? Is that okay? Any question about that? So understanding either I give you an angle or rotations, or this understanding here. Everyone okay? Any questions? So that's a coterminal. It's really easy. It's adding or subtracting of multiples or rotations of 360, and where n represents the number of rotations. I apologize, it might be rotation or it might be revolution, I apologize. Like, I always get those two words mixed up, so if you look in the package, if it says revolution, that might be the same thing.
What's the difference?
I forget the physics connection right there. They're related. Rotation versus revolution, I can't remember. It might be in your textbook a little bit better. But I'm not going to specify that later. Everyone okay with coterminal? Pretty easy, right? Coterminal. Okay. So now, we're going to look at this radian measure. And we'll slow it down a little bit, and this is where you can ask me some questions. I think I did this on the circuit class, but just in case some people need it. Basically, my definition, a radian is actually related to degrees. It's another angle, basically, okay? And to illustrate why we're learning radians in the real world, like in physics and in sciences and math, we actually use radian measures everywhere, okay? It's actually the used unit. The radian measure is actually unitless, meaning it has no unit, but for us in grade 11, it's our first exposure really. I'm going to emphasize using rad for short for radians. So what I've actually drawn is a unit circle just to illustrate what I'm trying to teach you. And notice I went counterclockwise just so we're going to keep it consistent, right? So one more time, I think I did this in the synchro class, but I'll do it again. The definition of circumference, the distance around, it's really called perimeter, but for circles it's circumference. The equation is 2 pi r. That's what someone said to me like online, I think pi d. But I like using 2 pi r because it's the radius there. So if I go all the way around, I've gone to a complete circle now. If r is equal to 1, the circumference that I actually went is 2 pi. Or more importantly, to help everyone out, I went all the way 360 degrees, but actually I went 2 pi radians. Okay? Everyone see that? So 360 is the same thing as 2 pi. Similarly, a lot of you realize in blue chalk, I only went half the distance, right? So instead of going all of 360, half of 360 is 180. A lot of you realize half of 2 pi, that's pi radians. Everyone see that? So it's a distance traveled from there to there. Now in the package, it talks about arc sectors and sector lengths and everything, and that's great and everything. That's actually the true definition. But for us in grade 11, seriously, this is all we need to worry about. Notice again, half of 180 degrees is 90 degrees. Can someone help me out? It's half of pi, no pressure.
Pi over 2.
Yeah, pi over 2. Half of pi is half of pi. It seems silly, but I like doing it. So some of you are slowly seeing it now, right? I know it seems weird because when we talk about the Cartesian plane, x and y, remove that. They're actually quadrants, right? And so each of these quadrants or quarters are 90 degrees. They're quarters, right? So you're basically looking at each quarter that helps us out. So from 0 radians to half pi to a full pi. So between 1 pi and 2 pi, there's something in between. Right? And this is where a lot of kids get mixed up. Notice some people will try to say 3/4 because it looks like 3/4, but it's not, right? This is 1. This is 2. So halfway between 1 and 2 is
3 over 2.
Sorry?
3 over 2.
3 over 2. Right? And so that's what we have for our special angles, 0, 90, 180, 270, 360, which some of you are already kind of seeing. So notice I really didn't tell you what 1 degree is and how many radians that is, or I didn't give you 1 radian, well, 1 radian actually. 1 second.
I'm so sorry to interrupt.